reflection, refraction, diffraction. Just to review, this is a transverse wave. We have crest, trough. From a crest to a crest and a trough to a trough is a wavelength. From the middle of the wave to the crest is the amplitude, or the middle of the wave to the trough. Now, frequency, here we can see 1, 2, 3, about 4 crests of frequency and 4 troughs of frequency in the wave. If there were more, then we'd say it was more frequent. If there is less, then we'd say it's less frequent. This is a compressional wave, also known as a longitudinal wave. And this is the slinky. You can see here, that's a compression. Here's a compression. These are rarefactions. From a compression to another compression, that is a wavelength. Compression to another compression, that's a wavelength right there. All right, just to review amplitude and frequency. For this side over here, which wave has the lowest amplitude? That would be number 4, and the highest amplitude, that would be number 5. So that's how you can see amplitudes. I can also say maybe number 6, if I'm comparing number 6 and number 5, that number 5 has an amplitude that's about twice as much as number 6. Or number 6 has an amplitude that's twice as much as number 4. Now with frequency, I can look at the crests or the troughs. Now I can say that this wave down here has a higher frequency than this wave here. This wave here has a lower frequency, less frequent than this wave here. Is it 1, 2, 3, 4? I'm going to count off of the same grid, so I'm going to stop here. 1, 2, 3, 4, 5, 6 crests. 1, 2, 3. This one has a higher frequency. Okay, new stuff. Waves do not have to travel in a straight line. They can change direction when they travel, and they change direction usually when they travel through different mediums or materials like solids, liquids, or gases. Very important. They can be reflected, refracted, or diffracted. Reflection is just what you think it is. Here is a lake. You can see the reflection of the sky, the reflection of the mountain and the trees in the water. So the law of reflection says that the angle that a wave comes in is the angle that it goes out. That's all it says. So let's look at this picture over here. This angle, it goes out at that angle. If it comes in steep, it goes out steep. You see that? If it comes in gradual, the light, it goes out gradually. So we can say that the light is bouncing off of something. It's reflecting off of something. When you look at yourself in the mirror, that image, the light is bouncing off of the mirror, the image that you see. You see it at the same angle that the light is coming in and reflecting back at you at. I know it sounds crazy right now, but you just need to remember that the angle that the light comes in is the same angle that it goes out. If the light were to come in down here at this angle, then it would go out down here at this angle. This is all reflection. Have you ever seen someone catch maybe the sun's light on their watch and then they try to direct it into somebody's eyes or their face? They're playing around with reflection, with angles of reflection. Refraction. The speed of a wave depends on the material that it's going through. A great example of this is a light wave. It travels faster through air than it does through water. So this is light from maybe a high-powered flashlight. And then as it goes through water, it seems to bend here. So what's happening is light is traveling very fast here, and then once it hits the water, the waves, the light waves slow down, and it looks like it's bent. And can play different tricks on you. Refraction of light. This arrow is pointing one direction. We're looking at it through air. If we look at it through a different medium, water, it points in a different direction. Air, water. Here's another example. Pencil and water. If you look at the top, right where it goes in the water, you can see the pencil looks like it's bent a little bit. We know the pencil's not really bent, but the light is bent as it enters the water. And down here, below the water level, the pencil on the bottom seems fatter than the pencil on top. That is refraction as well. Diffraction. Diffraction is simply the bending of waves around an object. So let's say we have waves going in here. Let's talk about water waves for right now. We have waves going here, and you've got a wall, and the wall has a little break in it. The waves cannot travel through the wall. You know that. So what happens is they bend, and the wave comes through this opening and then starts to get bigger as it goes through the opening. If there's an object in its path, like this one, the waves will come to the object and bend around the object. It can't go through the object. This is the simplest way I can think of to describe diffraction. Let's say there is a brick in the water, shallow water, and someone dropped a rock or a pebble, and that pebble would make ripples. It would make waves, right? So when these waves get to the block, they're going to bend around the block. They don't go through the block because it's a solid, obviously. So it just kind of bends around the block. That's diffraction. Okay. So let's look quickly at your homework. So basically, your homework is going to be a review of reflection, refraction, diffraction. You have your worksheet here, and you have a sheet here where you just have to name each one here, and then figure out which picture goes with which word and drag the picture up to the word. Now remember, if your paper is going to look like this when you get it and it's small, come over here, click on 100, and then I'll make it bigger. All right, have a good day.